Hi, everyone. Thank you for joining us today. Today, virtually, we have an alum, Mark Lardas, as an engineer, freelance writer, amateur historian, and model maker. He's originally from Ann Arbor, but has lived in Texas for many years. He graduated from the University of Michigan with a bachelor's in naval architecture and marine engineering. And then spent most of the next 30 years as a space navigator and software engineer on the Shuttle Program. He's the author of 17 published books, all focusing on history, which 10 are related to the maritime and naval, 10 related to maritime and naval history, correct, Mark? So thank you so much for joining us today. We're happy to have you virtually. And with that, I'll let you take it away.
Okay. I was invited to speak here in large part because they were looking for people that had naval architecture degrees, but had, shall we say, unconventional careers. You wouldn't think that working in the space program would be a natural fit for someone with a naval architecture degree. And yet, for most of my life, that's where I've been. So let me go ahead and give you some background on myself. As was mentioned, I am an Ann Arbor native. My dad moved here to get a degree at the University of Michigan, fell in love with the town and stayed. And he also met a local girl that he fell in love with and married. So I grew up here. The university was always part of my life. I was born in 55, so things start to come into focus about 1960. And at that time, the country had gone rather space crazy. They were just starting NASA. Project Mercury was going to be the next big thing. And I actually remember sitting through the first Mercury flight in my kindergarten class and the first Orbital flight in my first grade class. And one thing about being in Ann Arbor in the 1960s was the University of Michigan was really part of the whole space program at that time. So where most normal kids grew up following baseball players and trading baseball cards, my friends and I were really following astronauts. And, we even put together a pool of our favorite astronauts, kind of like fantasy baseball, only you got points every time one of them went into orbit. So that was part of my life through most of the 60s and 70s. To give you an example, when I was in Cub Scouts, we had John Glenn come and speak to my Cub Scout pack a couple of years after his flight. And at the time I thought, oh, well, he's just going around visiting Cub Scout packs and speaking to them. In actuality, he came at the request of Harm Buning, who was then an aerospace professor at Michigan. And Buning had helped with the Mercury program. So he knew Glenn knew him, and oh yeah, Buning's son was in the Cub Scout pack, so let's give Harm Buning Jr. something to talk about and brag to his friends about. But that's kind of the environment that I grew up in. And of course, in the 70s, as I am approaching graduating from high school, I'm at the first point in my life where I have to answer the question, so what do you want to be when you grow up? And that happened to coincide with what was called the big aerospace bust, where you had stories about people with PhDs in aerospace engineering not being able to find anything other than jobs pumping gas. So the bloom had sort of come off aerospace, but at that point I decided that I was going to become an engineer. And this was despite an interest in history. And actually my high school counselor said, but you love history so much. Why aren't you going to major in that? And I said, well, because I do love history. I want to make it, not just write about it. And at the time, I thought engineering was the way to do that. And actually, if you look at the history of this country from 1970 to 200, it is very engineering focused. And a lot of that was in the computer sciences rather than, say, space travel and stuff like that. But I actually made a pretty good bet on engineering as a career where if you want to make a difference, that's where you go. But of course, the two things that I absolutely knew as I approached graduation, high school graduation, was I wasn't going to go to a university in my hometown, and I wanted to go to the best engineering university in Michigan. And that is what mathematicians call a null set, because at the time, and still, the University of Michigan still has the best university college in the state. And yeah, I thought about Michigan Tech up in Houghton, but that's kind of cold. And even back then, I didn't like cold. So, okay, I'll go to Michigan. And they had a career day there where they invited high school seniors, and every department had a speaker. And actually, Buning was the speaker for the Aerospace department, and he had remembered me. For the Naval Architecture department, the speaker was Professor Benford. I don't know if any of you know Benford or have heard of him, but he was, back in '73, he was a remarkably dynamic and exciting speaker. And since I knew that I didn't want to go into aerospace, hey, this naval architecture stuff, that sounds kind of fun. And so I made that my major. And I was going to design ships. And that was the career I had planned. So get into Michigan, and back then, you could work part-time and earn enough money if you had the right job to pay for most of your tuition. And because I had grown up in Ann Arbor, I was lucky enough to get a job at Michigan running a computer. And it was in what was then the Space Science Building, which I believe is across the street from what's now the Naval Architecture Building. Is that correct? Nobody's going to answer. You guys are there. I'm on. But but that was on a NASA contract. When that, and I did that for about 3 years. What was fascinating about that was they had this big mainframe computer that took up most of a room. And we're talking about something the size of the room that you're in. And one of the questions I asked was, since the computer was only being used when I was running it, was, gee, in off hours, can I use the computer? And as far as the researchers that I was working with were concerned, hey, this was great, because that means this kid's going to learn how to use this mainframe. So they said, sure. So for my freshman and junior year, freshman and sophomore year at Michigan, I literally had a personal computer. And this was in 73, 74. And you know, those laptops that you have, this thing had a lot less power than those, but, and it filled up a room, but I could use it for my engineering homework, which was kind of cool. So even from the beginning, I was ended up pushed into computers. And then a few years after that, I ended up getting a job working for the Applied Mechanics department, putting together a computer database. And this was before databases were really around. This was one of the first ones. And at the time, I was too dumb to realize I was making history with this type of stuff. But it was a fun job too. And then, of course, I get to my senior year, and it's time for me to get a real job. And of course, I did what most of you seniors are probably doing now, which is I went down to the placement center. And back then, what you did was you went to the placement center, which was in East Engineering Building. And I think it was in the basement of East Engineering Building. At any rate, they had a bunch of flyers up showing which companies were interviewing and what degree programs they were interested in. And in my case, I was, of course, looking for naval architecture. And I ended up interviewing at a number of different companies. Avondale Shipyards was one, Pascagoula was another. I ended up interviewing at Illinois Institute of Technology's Research Institute, running a computer, but went out and also interviewed at Electric Boat in Groton. And that was a fascinating interview because they told me, oh, you'd be just perfect for our quality assurance department. I didn't apply there. I thought about it, wasn't interested. Well, a couple of years later, the Groton shipyard got busted by the federal government for committing fraud in the nuclear submarine program, particularly when it came to quality inspections. So ever since then, I've always wondered, did they think I was perfect because I was a crook? Or did they think I was perfect because I would be too stupid to realize that they were cheating on the quality tests for these boats? I'll never get the answer to that question, but I always wondered about it. At any rate, when I was down there, I noticed that Lockheed Electronics Company in Houston, Texas, which was working at JSC, was looking for recruits. And one of the things that they had highlighted was naval architecture. And I looked at that, and remember, this is when the shuttle program is starting. And of course, in my youth, when manned spacecraft returned to Earth, they were in a capsule that landed in the water. And well, that made sense that you'd have a naval architect. You might want someone with a naval architecture background for that. But I couldn't figure out why the space shuttle needed anyone with a naval architecture degree. I looked at that, scratched my head, and finally said, well, there's only one way to find out, and that's interview with them and ask them. So that's what I did. I signed up for an interview with Lockheed at Houston, and when they came, we went through the interview, and about 2-3 minutes into the interview, the engineer that was interviewing me looks and says, you've got a kind of funny background and degree for this program. And I said, yeah, I was wondering about that because it was highlighted in the invitation. And, you know, what they used to do back then is they would go over the various degrees that companies were interested in with a yellow highlighting pad. And we went and checked, and sure enough, it was highlighted. And we said, oh, well, the only thing I can figure is that must be because Lockheed has a shipyard in Seattle. And I know nothing about them. So at that point, we kind of looked at each other because this interview was going to be a bust. And finally, I looked at him and said, look, you're here and I'm here. Why don't we go through the interview and see what we have to offer to each other? And he thought about it and says, okay. And he goes through his pitch, talking about what they're doing and what they were interested in. This was a dynamic analysis group, and they wanted to do, one of the things they were looking for was somebody to do a vibration analysis of the shuttle. during assay. And he works out this vibration matrix and fills out some of the answers. And I'm listening to this, and coincidentally, I was taking ship dynamics that semester. And we had covered this exact thing in the class the previous day, vibration matrix. And I looked at it, and I'm an invariant fiddler. So while he's going on with what they're doing, I'm filling out the blanks in the matrix. And he stops, and he looks at me, and he looks at what I'm doing, and he picks the thing up, and he looks at it and says, "This is right." And I said, "Well, yeah, we covered it in class yesterday." And he said, "You can do this? It's actually simpler, because if you think about it, the shuttle's moving through one fluid media, air, and the ship is moving through both water and air." What I didn't realize at the time was that NASA was going through a massive growth with the shuttle program. It had started in '76, and they had built the prototype, which was the Enterprise. And then what they were going to do is, the original plan was the first launch was going to be in late 1979. They were screaming for people. Among the cohort of people that were hired that year straight out of college were a lot of, in my group, there was one education major that had a math minor. So that's how desperate they were for people. All of a sudden, I had shown up, even though I didn't have the traditional aerospace engineering degree or mechanical engineering degree. I ended up having the skills they needed. So they made me an offer. And this was in Houston. And I thought about it. And at the time of the other jobs that I'd gotten offers for, I think I told you about the Groton one. Pascagoula at the time was building frigates for Iran, which was going through a revolution. Avondale Shipyards apparently was having financial trouble and would have gone broke. I had been given an offer in New York City for Naval Society of Naval Architects and Marine Engineers that had such a low salary that I would have starved there, and I'd gotten married earlier that year. And I thought about it, and I said, okay, this is what I'm going to do. I'm going to go to Houston. I'm going to work in the shuttle program for 3 or 4 years. At the time, Houston had a large offshore industry. And okay, I'll have my adventure in aerospace, and then I'm going to go back to my naval architecture roots and go ahead and be a naval architect and design offshore platforms. And I can dine out on my experience having worked on the shuttle program and having been a rocket scientist for the rest of my life. So I did that. I went to Lockheed and did dynamic analysis of the shuttle for a couple of years. It really was fascinating. It was a really interesting job. As I said, the program was growing. It was the hot engineering program in 1979. The problem was they were at the ragged edge of a lot of different technologies. It was underfunded, as all NASA projects are, and it started slipping. And we didn't launch in 1979, and we didn't launch in 1980, and we didn't launch until April 13th, 1981. That was the first launch. And by that time, NASA management at JSC was announcing that we'd scheduled the launch originally for March, and they were proclaiming we will launch in March. And basically, it kept slipping, and finally these calendars began appearing, showing a shuttle taking off, artwork of a shuttle taking off with the caption, "We will launch in March." And it was 1981, and it was January, February, March for the rest of the year. So we did launch in March, if March had a March 43rd. During that time, I was doing dynamic analysis of the shuttle. Then I ended up getting a little bit bored with that and heard about a smaller company that was doing navigation analysis. Now, what's interesting is that, and I would end up doing space navigation probably about 30 years. And of course, what's interesting about space navigation is it isn't exactly like navigating a ship. When you're navigating a ship, you pretty much know where you are. Space navigation ends up being figuring out pretty much where you're not. You never quite know where you are. The idea is that you're going to reduce the uncertainty in your position to a tolerable level. And for the shuttle, that meant you needed to know where you were, really plus or minus about 20, 30 miles. Okay. If you knew where you were within that block, that meant when you did the deorbit burn to land, you would have the capability of putting the shuttle on the runway at the end of that. And of course, the thing is that once you do the deorbit burn on the shuttle, you don't have any power and it's all gliding from there on out. You don't have a chance to go around if you miss the runway the first time. So, and that's actually what I ended up doing. For 3 years, I was working real-time shuttle navigation, where my job was to figure out the shuttle's position and compare that to the onboard state of the shuttle. And when the onboard state got diverged from reality by a large enough margin, we would upload a new state vector to the shuttle. And it was actually a lot of fun because I'm between 5 and 6 years out of college. Ann Arbor, of course, being my hometown, I'd come home, I'd see some of my old high school friends, because we hadn't drifted apart at that point. And they would look at me and they say, "So what are you doing now?" And I would say, "Oh, I navigate the shuttle." And they'd look at me and, well, I've always been kind of on the chunky side. And they would look at me. And then finally, one of them would say, "I didn't know you were an astronaut." Because, of course, back then, when you thought of navigators and aircraft or spacecraft, what the navigator's part of the flight crew. Except, of course, I was being left on the ground with all the rest of the excess baggage. We were just uploading states. Any rate, so that's what I was doing in the mid 80s. And in 85, I'm thinking, okay, I'm going to move back to naval architecture. And then what happened was something known as the Great Oil Bust. And the oil industry just cratered. And Houston got very badly hit by that. So just as I'm putting out applications at various offshore companies, there aren't any jobs there. But that's okay, because I was doing quite well at NASA. Oddly enough, the naval architecture degree was part of the reason for that. And basically, that was because at the time, the naval architect was often the only engineer at a shipyard, and you had to do a little bit of everything. You had to know how the electronics on a ship, the electrical system on a ship worked. You had to understand the water distribution, the engineering, power plant. You had to be a generalist, and you had to look at things from a top-down perspective and be able to integrate various different parts together. And aerospace engineering was the opposite of that. People focused very closely on systems and parts of systems and couldn't see the big picture. And a lot of what you are doing in space, in any type of spacecraft, is you have to look big picture. And to me, I wasn't just looking at how the space shuttle navigated. I was looking at, well, how does the reaction control system interact with your navigation? How do the various math models and the various the computer software that's used to maintain the shuttle work with your assumptions? So I ended up being pretty successful while everyone else was just focusing on the details. And whenever anything odd came along, they would give it to me because they didn't know what to do with it. I figured that I would. An example of that was one of the shuttle experiments involved attaching a 1,000-pound payload to the shuttle by a 20-kilometer long tether. And if you're interested in orbital mechanics, it's a fascinating problem, but it's more than just a orbital mechanics problem. And when we did the first sim, what ended up happening was that the orbiter during the deploy period, which was 36 hours, the orbiter lost 10 nautical miles in altitude. Now, that probably doesn't mean anything to you, but what that means to someone that knows orbital mechanics is there was a tremendous loss in orbital energy, and nobody could figure out what was going on. The people that had designed the tether mechanics model said that it had to be the fault of the navigation system. The control system people said, no, it had to be the fault of the tether model. That had to have been screwed up. Everyone was blaming everyone else. I took a look at it from the standpoint of, okay, let's assume everything is working right instead of everything is working wrong, and decided to check the jet firings, and discovered that basically, in order to maintain the shuttle at an attitude where it was pitched up 30 degrees, they were constantly firing the RCS jets in the forward direction. And thing is that these are 25-pound jets. They aren't very big. But if you do that continuously once every 3 minutes for 36 hours, you're going to reduce the altitude that the shuttle's flying at by 10 nautical miles. And everyone looked at that and said, oh, that's what went wrong. In other words, the tether model worked right, the attitude control system worked right, the nav system worked right, but you had to get above all of that and look at how they played with each other, how they worked with each other. And then once people had that clue, my question was, well, why are the jets firing? Well, it turned out the jets were firing because they had set the orbiter to be in a 30-degree nose-up attitude so that basically, when you're orbiting, a system orbits around its center of mass. And if you've got a tethered satellite, something tethered to another, if you've got two objects tethered together, what will happen is the tether will line up along the radial axis of the Earth, and it'll be like a chain from the upper object to the lower object straight to the center of the Earth, because gravity is pulling the whole system so that it is orbiting that way. And they took 30 degrees as a guess. What we discovered when we looked a bit further was they really should have commanded the orbiter to have been at a 27-degree pitch up attitude, and then that would have lined the center of mass of the orbiter with the center of mass of the tethered satellite with the Earth's center. They also ordered a 3-degree deadband on the attitude, which meant that once you got 3 degrees further away from the commanded attitude, they would fire the jets, push it back to the desired attitude. And so what that meant was we're commanding the orbiter to hold a 30-degree nose-up pitch. The tethered satellite is pulling the nose down until it hits 27 degrees, at which point the jets fire, push the orbiter back up to 30 degrees, and slow it down a little bit. And when they stop firing, the tether mechanics pulls the nose of the orbiter down to 27 degrees. It hits the deadband, it fires the rockets, and this continues for 36 hours. And the solution ended up being very, very simple, which was set the deadbands to 10 degrees during after you deployed the satellite. Find out what attitude the shuttle is happy at, whatever it's going to be. It's going to want to be at that attitude, and then command that as the desired attitude for the shuttle. And when they did that, there were no jet firings because the orbital mechanics were forcing the shuttle to be in a standard fixed position. And everyone was happy. But it's like I said, if you didn't step away from the program and ask the big picture of, one, what's going on, and two, why is it behaving that way, you can never get to the solution. Of course, the problem with that is that's kind of an odd skill to have. Any rate, I ended up working on that program for a while, and then the Space Station Freedom came along. This would have been in the late 1980s. And I decided to switch to that, doing essentially integration of the avionics in what was supposed to be America's space station. And then, and I should mention that in '86, we ended up blowing up one of the shuttles, and the shuttle program went into a freeze, and the company that I was in shrank from 1,200 people to 300 people. And I remember at the beginning of that, somebody asking me if I was going to go over to Rockwell, which had won a contract and had guaranteed jobs for everyone at the company I was at, which was McDonnell Douglas. But, oh, by the way, you have to take what's essentially a 10% pay cut. And I remember saying to a friend of mine was asking, well, you're going to go over to Rockwell. I said, no, I'll stay with McDonnell Douglas. He says, but why? And I said, well, I figure at the end, maybe they'll lay off 50 people. I don't think I'm one of the 50 worst people in the company. I don't think I'll get laid off. And of course, what happens is, who are the first 50 people to take that job offer from Rockwell? Oh, yeah, they're the 50 worst people in the company because they know they're going to get laid off if they don't go. And then the next 50, and the next 50, and the next 50. And essentially, about 600 of the people that were in the company ended up going over to Rockwell. Not all of them were really bad engineers. They cherry picked and got the superstars. And I'm sitting there, you've heard of the organizational triangle. By the time we were done, it was an organizational diamond with senior people on the top and one very, very junior engineer left, and that was me. So I never took that for granted again. And again, so now we go into the, after that happened, I went into navigation analysis, and that's where I ended up doing the tethered satellite analysis I was talking about earlier. And then I decided, well, let's go into the space station because that was the hot topic, and ended up getting to be part of a team that was going to integrate what was going to be Space Station Freedom. And McDonnell Douglas built a big facility on the south side of what's Ellington Field. Nowadays, it's the Sonny Carter Training Field, original training center. Originally, it was where they were going to assemble the space station. They ended up putting a big swimming pool in what was supposed to be a zero gravity floor, and used that for training astronauts in shuttle EVA operations, and still being used for that space station. But in 1994, Congress canceled Space Station, the Space Station Freedom. And the group I was in shrank from 30 to 25. And at that point, I decided I'd had enough of aerospace. I had done a lot of work in computers, and there was this new thing opening up called ECommerce. So I ended up taking a job in Palestine, Texas, working at something called an ECommerce training center, research center, and ended up being an e-commerce expert for the next 8 years. And, Palestine is in deep East Texas. It has the same relation to Texas that kind of Michigan's Upper Peninsula has state of Michigan. It's not quite at the edge of the world, but if you stand up on tiptoes, you can see it. Regardless, it was an interesting 8 years. And again, I developed a number of other skills, including presentation skills, being able to put together training materials, giving presentations to small businesses about how to use electronics and computers and all the stuff everyone takes for granted today. This was back in the day when HTML was brand new. And for a few years, I was probably one of the leading HTML experts in the country, because when it's a year old, it's easy to be one of the top people. So Uh, at any rate, I discovered that e-commerce ends up being as cyclical or worse than aerospace. And what ended up happening was you ended up getting the Dotcom Bus in 2000, 2001. And the contract that I was on was a Defense Department contract because we were supposed to be teaching small businesses that contracted with the Defense Department how to use electronic commerce, how to use personal computers, how to use bid boards, things like that. And the contract was due to end in September of that year at the end of the fiscal year. At that time, we expected the contract to get renewed, but I decided that maybe it was a good time to get gone. And I was looking to get out of rural Texas into a more urban environment because by that time, my kids were getting old enough to start going to college. And I wanted to be a little bit closer to where they would be going to school. And so I'm looking for work based on my experience as an e-commerce computer guru. And on September 9th, 2001, I had 4 job offers. I hadn't accepted any of them because I was supposed to interview at Lockheed, at JSC the following week. And I wanted to see how that went. I suspect most of you are too young to remember September 11th, 2001. That's probably to you what December 7th, 1941 is to me. However, after the Twin Towers fell, the very next day on the 13th, on the 12th, I end up getting calls from all 4 of those companies saying, we've got a hiring freeze on. And on the 14th, I get a call from Lockheed saying, we've got a hiring freeze on. And then the Army says, you know, we don't really need to worry about contracting. We need that money for trigger pullers. So they ended the contract, and I ended up without a chair behind me when the music stopped. And I ended up being laid off for 9 months. Now, at that point, the question is, what do you do? I was looking for jobs everywhere. And then about 8 months after I'd lost my job, I had been applying to jobs back at JSC because I was just desperate for a job. I ended up getting a call from someone that I had worked with at McDonnell Douglas back in 1986 when they had laid off all these people. And at the time, I'm always been a pretty good writer. Part of my success as an engineer is the ability to take stuff and translate it in from engineering into something normal people can understand. And that included things like putting together resumes. So I ended up helping a lot of the junior engineers that were going to end up getting laid off, put together their resumes. Any rate, I ended up getting a call from somebody who was a branch manager at NASA. And he told me, I understand you're looking for a job. And I said, yes. And he said, well, let me know which ones you're looking for, and I'll see what I can do. And then I saw something working for one of my bosses that I'd worked for at McDonnell Douglas. By that time, it ended up getting purchased by Boeing. And they were looking for someone to do shuttle onboard navigation because Boeing was moving its shuttle navigation engineering from California to Houston, and none of the Californians wanted to move to Texas, or very few of them did. Any rate, he gets me the name of the hiring manager, who's an old boss of mine, and I called him up, and his name was Guy Hirsch, and he said, he remembered me. He says, boy, I haven't heard from you for a long time. What's going on? I said, well, I understand we each have a problem. He said, what's that? I said, well, I understand you're looking for someone with shuttle navigation experience. Yes, well, that's true, he said. And I said, well, I'm looking for a job. So I went and interviewed and ended up getting back into the shuttle program, except this time, instead of doing ground-based navigation, I ended up working on the onboard navigation, and in particular, rendezvous navigation, because the shuttle was basically flying up to the space station by that time. This was in 2002. And, you know, basically all of the people that had pioneered that back in the 1980s had moved on to other things, and it wasn't considered a hot engineering topic. But for me, hey, it was fun, it paid salary, and I ended up staying with that through the end of the shuttle program. At which point, this time I knew what was coming. And basically, by that point, I've got 25 years experience. What are you going to do? And people say that once you're in your 50s, you will become unemployable in engineering. And I'm going to tell you that's true only if you are unwilling to learn new things. So as we're waiting for the shuttle program to end, I've asked myself 3 questions. And that was, what am I good at? Second one was, what do I like doing? And the third one was, what are people paying for? And basically, the intersection of those 3 questions was technical writing. And while a lot of my contemporaries decided to wait until aerospace came back, I ended up spending 10 years doing as a technical writer for a wide variety of companies. National Oil Well Varco, where I learned all about how to drill oil wells and document that. Camden Living, where I did middleware for their apartment rental site. Chevron, I ended up learning about oil trading. United Airlines, I learned all about the reservation system. Ended up doing that for about 10 years, bouncing around from one job to another. And oh, by the way, having a lot more job security than I did working at NASA. And then last July, I ended up getting a call from a company called CACI. And part of the reason I moved down to Houston was, in the back of my mind was the idea that someday I'd work on the Return to Moon project. Now, that wasn't as crazy in 1979 when we were 10 years away from the shuttle, from the moon landing, as it may sound today. But if you told me that 30 years later, we'd still not have gotten further from Earth's surface than 300 miles, I'd have laughed. I'd have thought that was a joke, but that's what turned out to happen. At any rate, we are finally returning to the moon, and it turns out that NASA is desperate for people, that particularly someone that can look at a program and say, these are the pieces that need to fit together. So I ended up getting back at NASA on the Lunar Gateway program. So I guess I'm going to have to wind this up because we're just about at an hour. But part of what I'm trying to get across is opportunities arise when you least expect them. If you're flexible, you can take advantage of them, and that every crisis is also an opportunity. So I guess there endeth the lesson. Does anyone have any questions, or if I put everyone to sleep?
Anybody? Questions? None?
I guess I put everyone to sleep.
No, they're awake. Tony's got one.
You asked what his favorite job was.
What was your favorite job?
Oh, the one I'm doing now, always. I mean, that sounds silly, but it was the one thing I'll say is most of what I've done has been fun. It was fun learning about the vibration analysis, and then when that got dull, I switched to a job where I was learning about navigation analysis. You know, the various tech writing jobs I had were really cool because I guess I'm a perpetual student. So the only part that wasn't fun was the last few years of the shuttle program, because I knew it was ending, but the problem was if I stayed until it ended and got laid off, I would get the equivalent of about 14 months pay as a retention bonus. So I knew that the space program was going to be dead for the next 10 years after 2011. So I ended up having to thread this needle between being not good enough to be retained and not bad enough to get fired. So, but, you know, I did. The thing is, if what you're doing isn't fun, if it isn't a challenge, find something else. That doesn't mean run away from hard work, and doesn't mean don't do the tedious stuff that's part of every job. But if you're not proud of what you're doing, really find something that you are proud of.
Good. Thank you. Anyone else? Question? Andrea, 1 second.
Which of your jobs gave you the hardest learning curve?
That's a good question. I would say I think it's actually the one I'm working on right now, because when I left JSC in '94 and came back in 2002, nothing had changed. But when I came back in 2020, everything had changed. I don't know whether it's because I don't think it's because I've grown old and fossilized. I think it was just because NASA had moved on from what were frankly some obsolete infrastructure that they had at the end of the shuttle program, but suddenly everything was new, and I ended up having to run the Red Queen's race, where you go as fast as you can, just stay in place. But I think I've mastered that, and I'm actually useful to the group I'm in after Well, now it's 8 months, but after 6 months, I began to feel I was actually contributing. Actually, one of the biggest problems most people have is a fear of failing. You want to be the best that you can, but you can't be good until you're bad at something. So, go in there, fail, do it again until you succeed. Fortunately, I've got a boss that understands that. I've worked for someone in the past that just undercut anyone that was working for them.
Anyone else? Mark, I'm going to share your website so that the students can see your books
Okay.
and your models.
Yeah, I haven't updated that in a while. I've got something like 40 plus books written now.
And when's the last time you've been in Ann Arbor?
Last March, as a matter of fact. No, last April. My father ended up dying in 2018, and then my mom died last year in March. So I came up to help close the estate.
All right. Well, next time you're here for happier reasons, come by and visit.
I will. I would have taken you up on the offer to be here in person, except for all the COVID madness.
Yeah.
I really didn't feel like flying on an airline with a mask that did nothing except increase my CO2 content.
Good. Understandable. Well, hopefully we're getting past that. Well, thank you so much. Thank you. Round of applause. Thanks. We appreciate your time and hopefully we'll see you in Ann Arbor sometime soon. Bye-bye.